Wow, what an awesome start to the event. Thank you so much, Shalvi, for that awesome keynote and for kicking us off today. Hi, everyone. I'm Kyle Kerwin. I'm the co founder and CEO at Big Eye, and I'm excited to lead you through the second track of today's event. So, without further ado, I'm pleased to welcome Miriah Peterson. She's a data reliability engineer and a member of the technical staff at Tailscale. Miriah focuses on scaling data infrastructure platforms and pipelines, and today she's going to present her talk, Where We Are Going, We Don't Need Standards. Over to you now, Miriah.
Thank you so much, guys, for coming to my talk today. I am Miriah Peterson. I am a member of technical staff at Tailscale now. That is different than in the talk description. I did change positions recently, but I'm very happy to be speaking to you guys today about some of my experiences in startup world and trying to adapt to a more data-centered and reliable pipeline. So we're just going to start a little bit talking about the startup space. In my startup and in many startups, the most important thing is speed. We for a time adopted the Mark Zuckerberg motto, move fast and break things, because there is a real need, a real urgency to find the right product, to find the market that fits that product, and to be able to see the success of that product in the market. This does invite a lot of beneficial and really exciting workplace practices. One, you get to do everything production first. You don't have to worry about little changes. You just get to deploy things quickly and move really fast. You get a really quick feed loop from your customer, because they are everything. They are what's breathing your lifeblood, and there's not a whole lot of middlemen between them. It's very much you deploy a feature and hear back immediately. And then another thing, creativity is most important. We want to know how you can creatively solve problems quickly over sometimes even standard practices. And this is a very special place to work, but we oftentimes think that startups are unique and special and don't necessarily need a lot of good practices, and they often forego a lot of good practices, which gets, the converse of what makes it special is you end up with a lot of sacrifices. You don't see a lot of forethought as far as architecture or planning goes. You don't have a lot of clean code. You don't have time to refactor. You don't really get to make sure that your code is readable or legible. And you often forgo a lot of things when it comes to security, governance practices, or really any kind of protection for your code against long-term errors or bugs or vulnerabilities. So what happens when your startup is successful and you have to now take it to that next level? You now have to now scale that quick fix, quick to production code base. What usually ends up happening is you end up, or at least with what I've seen, is you end up with a lot of duct tape architecture. You end up with lots of patches, lots of band-aids, lots of quick fixes, and you just kind of, as you're trying to scale and get it to more customers, you find new edge cases, and you really don't have time to build something brand new. So as soon as something breaks, you find a quick piece of duct tape, put it on it, and move on to the next problem, hoping that your whole system doesn't crash before you have time, money, and resources to build out that infrastructure. So this was literally the situation that me and my team found ourselves in. We had a system of band-aids and duct tape pieces holding together an entire ingress framework for third-party data. And it was kind of scary. It There were times when one merge did take out systems and we had to go into emergency mode. So it became really, really paramount as we got additional resources to kind of dedicate those resources to better reliability and better infrastructure practices. So we created a team, and that team was specifically their whole goal was to kind of create avenues to avert the crisis situation. They were working on our data pipelines, making sure we created pipelines, that we managed data, that we were able to build gateways to expose our data to teams, um, and make sure that we did it in a way that was very stable, that was very available, that was very maintainable, and could scale from your 10,000 customers to your 100,000 to your million customers. And we were with this kind of goal in mind. We sat around, the three of us on this team as it started out, and we were trying to figure out a name. We knew we wanted to have some kind of like data goal, but we weren't a data infrastructure team. We weren't like we have other people working on infrastructure, and we weren't building out a platform. We weren't a platform team. But as we were doing research, I came across a podcast where they started talking about this thing called data reliability, and that really aligned a lot with what we were trying to do. We were trying to make things more reliable. We were trying to apply these SRE style practices and procedures to our existing data services. So we made a DRE team, or a DRE team, as it was an affectionately memed to me on social media almost instantly. So what did we do? Certain things we definitely focused on as we were trying to make our infrastructure more stable. We focused on fundamentals. We had to figure out what the problem was. We learned something, we implemented it, and then we tried to iterate on it, trying to move keep that fast iteration, but still keep it based on learning and understanding the problem. We had to rely on our intuition. We had to be very trustworthy, made sure that other teams knew what we were doing, and we were trying to be examples of how to be more reliable so other teams could understand why these practices were important and not kind of extend that duct tape architecture model. And another thing we wanted to make sure that we focused on very importantly was we needed to make it work and then make it right. And those things were making it work was most important. Making it right or correctly or cleanly was second important, right? Making it reliable, making it with metrics where we could see, where we could observe, where we could act quickly. And then the last thing was speed, right? We still had deadlines, we still had things we needed to meet, but we needed to make sure that scalability and reliability were our first two priorities, and then speed came second, right? We had that product fit. We weren't trying to find customers. We needed to make sure that our customers had that best experience. And so to do that, our overall goal was we needed to understand the problems versus just engineering solutions without understanding why. So when we'll just go really quickly past these. There we go. So the first thing we needed to do was we needed to understand what our product was, especially to our data services. And to do that, we had to dive deeply into three very specific areas, being compliance, the compliance requirements of our data, the state of that data, and our stakeholders or our customers or our internal teams using that data. The first thing first with compliance, we do deal with PII and HIPAA data. We have credentials for how to access and log things. So we had to make sure that we were meeting the compliance requirements needed for any company, and especially a public company. So we did have to meet with compliance teams and understand what those requirements were, and made sure that we took that into consideration and when planning and implementing the future solutions. We needed to understand industry standard practices for the data, right? Dealing with medical data, there are HL7 requirements that are generally used for lots of APIs or connections or other internet connections or data transfers that generally outline how to use this data, how to transfer this data, and how to make it more interfacing with other external parties and internal parties. And these were good things we could implement and scale. They were a little bit more tried and true than trying to come up with something on your own. And then we needed to understand how we were treating different parts of our data. In the product data, the functional data we use for our day-to-day business logic, we do expect there to be protected data, and we do have to maintain compliance requirements there. With data we do analytics on, there are occasional cases where you do have protected data in there, but 90% of the time that should be obfuscated, and you shouldn't have to worry about those compliance requirements. And with things like metrics, with usage statistics, or other forms of metadata about your services, that should not have any protected data in there. And we needed to make sure we understood how each of those was being treated, and that each of those did maintain the correct standards of requirements. After dealing with duct tape architecture across data stores and other things, we needed to understand what kind of data we were storing and if it was in a good state. And this stuff ends up being pretty basic. Is the stuff we're storing the expected data the expected values we want to store? Are we storing duplicate data? Are we storing data we're not using, or do we even foresee a use case for using it, or are we just keeping it there to keep it there, right? Like, there's a certain point we can always get more data. Getting data is easy, but storing data unnecessarily makes it really hard to maintain as far as the software services, because then you end up doing extra cleaning and extra aggregation. It can slow down your database queries, and it really ends up to just evaluating are you wasting money doing things you don't need to do? Can you streamline it and make it a little bit more efficient by cleaning up the data? And when you understand who's using the data, we did work with product on this specifically to understand how other teams were interfacing with our data and how it was being used. So we did need to know what teams internally were using our data. We needed to know what endpoints they were calling, how they were accessing that data, the frequency they were accessing at. Sometimes the endpoints were getting called at 15-minute intervals, and sometimes they were being called on demand. How many services they went across. There were several times when we would have like daisy chains of microservices calling these data endpoints when it really only needed to be 2 or 3, not 15. We need to understand, is the data being cached, right? Do people cache copies of your data to use it in their services, in their applications? Because if it's being cached and copied, now we have to maintain some kind of equivalence in that data state. We have to make sure that things don't get out of sync and that they aren't being that we don't do anything that would invalidate their caches and their copies and basically invalidate the products that they're trying to deliver to customers. And we really tried to understand who the data consumer was from the service perspective, and additionally from the product perspective, to understand a little bit more of the why, and the what they were doing with that. So, steps we took into place, like I mentioned, we talked to the legal, security, and compliance teams. Something I want to point out there: if you have legal, security, and compliance teams, you're not really in startup mode. You're probably out of hypergrowth mode, and you should really be focusing on that stability. We did audit our database, to look at that data state, to look at the kinds of things that were being stored. We did make sure when we were doing that we weren't using any kind of identifiable information, clean that up. But it was a really good exercise to understand kind of what state we were in and what the problem space was. We had to leverage tracing to understand how many services were being called, what the latency looked like across our calls, if there were any like slow points or hot points, and then additional metrics into observability, leveraging time series data and other things to understand the efficiency, again, our hotspots, and make sure that also, as we were iterating on it, we maintained the promises or the experience that our stakeholders were using as we moved forward. So one of the things I wanted to highlight from this database audit that we did was this is just an audit of some of the metadata we were getting. These are just the top 20. We had about of a key value store, the top 20 most commonly stored values of a key value store. And we were expecting these to be pretty even across about 30,000 individual services that were, so we have 30,000 services that each have a key value store we manage. So we were evaluating that, and we were looking for something a little bit more even than this. But as you can see, we have a lot of hotbed values, a lot of very common values. We have a lot of duplicate values. And there was honestly a lot that aren't used actively used as part of the service. Some of these things were just used for quick visual checks. Things like the most used one, migration, has no functional addition to software. It's just something that a service rep could pull out through a UI and say, oh, migration checked, this is stable, which could be surfaced in a different way than giving a service rep access to a key value store. So a lot of these things were not necessarily useful, but as you can see, of 40,000 instances, only 25,000 have it. And there's a huge drop after you get past the first 15. And we were looking for a more stable style line. And then here we did a little edit of our system to see if we could categorize these key values into something a little bit more useful. We were, like I said, we met with compliance. We were trying to understand if there was a security need, and if there was a security need, we wanted to put those into their own bucket that could be encrypted and maintained according to those compliance. And so we just did a very quick text classifier to see, hey, based on keywords, can we categorize these? And it was successful. So if there are more categorizations that go around functionality, right? Like the credential ones were clearly used for logins. Configurations ones were used in setup of how we brought data across. State ones were used to record the state of our data pipelines. And unknown didn't really have a use case. But this quick categorization allowed us to introduce and refine functionality to make it so that our data stores didn't have to be accessed straight across for every particular use case, but each set could be accessed as needed based on use case. And it was a really easy thing to do with a text search to understand the state of the data and understand what we could do going forward to make it more efficient and more effective as we tried to scale. The next thing we needed to do, right, now that we understand the problem, we needed to be able to act on our stuff. So we definitely knew that we had to start leveraging our risk better. This is a common SRE practice. And I think this quote from the Data Reliability Engineering book sums it up perfectly. There is no way for any system to exist without failures. So we need to create a system that is resilient to failure, but when it fails preemptively, and it fails in a way that we can react quickly and decrease or minimize our time to resolution, so that our customer does not feel the impact of incidents and they do not see an increase in things like outages or downtime, etc. So as we were leveraging risk, like I said, we put in metrics. We needed to know if we were having major latencies, if things were taking a long time to query, if certain services went out, right? We had daisy chains of services. If one service went out in that chain, our latency spiked and we were not able to get those services. We needed to understand how our traffic went, what our errors were, and if we were ever saturating our memory in addition to our networks. So these are 4 golden signals of metric of observability, and what we focused on as we were leveraging risk to try and anticipate some of these problems. We set alerts around them so that we could, again, if we started to see a spike, we could preemptively act instead of waiting for it to cause a major outage in customer experience. Another thing that we looked at was this idea of data downtime, or sometime when the data is unavailable to a service or a customer, whether that be because it is incorrect, whether it be because the service is out, or because the data could have been not what they expected. It's part of these metrics and signals we were leveraging were definitely to understand our data and how the data was being used. We looked at not just our database calls, but we looked at the points when the data was being created and when the data was being manipulated to understand sometimes we were getting errors stored in our key value instead of the actual value, and that's something that increases our data downtime that we had to minimize or reduce or get rid of. We don't want to be storing errors at all as key values in order to create that optimal customer experience, and do it in a way where we could iterate quickly and make it so that our customers did not feel any side effects, if a minimal side effect at all. And the last thing that we tried really hard to do using these metrics and this information we put in place was to create SLOs, SLAs, and SLIs to meet the customer requirements, our stakeholder requirements, and also the partner requirements. We do interface with our third-party partners that we bring their data in, and we needed to make sure that we were keeping their expectations in addition to the internal expectations and our customer expectations. As we added these SLOs and SLIs on our data services, we were able to update and roll out features and know as we rolled them out gradually if there were spikes, if our metrics went out. We do use microservices and Kubernetes for our rollouts, and we do a staggered rollout, but we can still see those metrics at a pod level and get those things to be able to do a rollback and maintain that functionality. Therefore, decreasing our downtime as we were able to do a rollback and evaluate and keep our time to resolution small by doing quick feature delivery, by understanding what our promises were, and by making sure we always kept our promise and we had insights around them. So In summary, I think one of the important things we need to take away from this is that a lot of times we as engineers are pushed to engineer and create. In startups, that is what we do. It's always, how can you creatively solve this? What can you push out, get it to production, get it first, get it working. Um, but what we don't take the time to do is that we don't take the time to understand the problem. When we in our team and our company, we hit that wall where engineering was no longer solving our problem. Pushing things out didn't solve the problem. We had to understand what the problem was, get insights around that problem using our metrics, using our metadata, doing audits and understanding the compliance requirements. And then once we started understanding, we could then iterate over the problem to create a solution that was then better engineered, more resilient, and scalable across many services. And that's, I think, the key takeaway from this. If I could just emphasize it one more time, is you have to be able to understand what the problem is, understand the nuances of the problem, the edge cases of the problem, and then act on that understanding as opposed to act on what you think the problem is or what the hot spots of that particular time are. Um, Understand your problem space, understand the data space, understand how your data is being used, who your data is being used by, the systems that use your data, how many services rely on your data that you're storing, how many teams rely on it. Is it essential to production? Is it essential to your business intelligence teams? Is it essential to your C-suite? Is it essential to your customers? Understand the metrics and the metadata that is being used to describe your systems. That metadata is key. You can create insights, pipelines, alerts, and other things on this metadata that creates a better engineering experience, creates a better customer experience, and creates a more reliable overall experience for your customers. And then make sure as you roll things out that you do leverage risk in a way that increases your reliability. Things will break, but as they break, make sure you can catch those breaks quickly. You can decrease your downtime, minimize your time to resolution, and get fixes out in a way that customers don't even need to notice. I know that a lot of times you'll hear people talking about, oh, I've got 5 nines. And 5 nines, great, you don't notice a whole lot. But sometimes, even if you start at 3 nines, 2 nines, customers still don't notice a good chunk of the time. They can't be online 24 hours a day. So you can still create a reliable experience as you push to your 5 nines by getting good insights and by minimizing the downtime in ways that again minimize the customer experience. And I just want to thank you guys so much for allowing me to share my experiences today, to share what our DRE team went through as we tried to scale our services and make our data experience better. Feel free to catch up with me on any of my channels if you have any questions or you want to chat about this later. I do coding streams on Twitch, which is always fun. It's way more fun to chat about live. And I thank you so much for this opportunity.